Okay, so we are now in the last part of our discussion in parabola. Okay, so let us try to solve example 4 and 5. So example 4, an arc in the form of parabolic curve with a vertical axis is 60 meter across the bottom. The highest point is 16 meter above the horizontal base. So what is the length of the beam to be placed horizontally across the arc 3 meter below the top? Okay, so try to illustrate it. So for 4. Okay, so we have that base. Okay, so we have that parabola. Okay, so we have the parabola with this base here. Take note that the length of this base is 60 meters. Then the highest point, okay, the highest point is 16 meters. Okay, so we are tasked to determine the length of the beam which will be placed horizontally 3 meters from the top. Okay, so this is the top portion. Okay, so this is the beam. Okay, so that is the beam, guys. Okay, that is the beam. Should be placed 3 meters from the top. Okay, so say that length of the beam, say that is L. Okay, so what we will do here is square property of parabola. Okay, so recall. So this is the square property of parabola. So what we will do here is we have the height 3 meters from the top, then over length squared. Okay, that is for the small parabola here. Okay, then that is equal to, so from the top to bottom, so we have this 16, then with the base 60. Okay, so that is 60 squared. So therefore the length of the beam is equal to 25.98 meters. Okay, so as simple as that. So you just have to analyze it. Okay, some of the applications for parabola is using the square property of parabola. Okay, so that is for number 4. Okay, for number 5, for the last example, so the actual cross-section of a headlight reflector is a parabola with the bulb's center as the focus. Okay. Find the depth of the headlight in cm, knowing that the bulb center is 2 cm from the vertex and the radius of the base of the headlight reflector is 10 cm. Okay, so what we will do here is again illustrate. So we are tasked to determine the depth of the headlight. Okay, so this is our Cartesian plane, then this is the headlight. Okay, so this is the vertex, then the bulb is in here. Okay, so the bulb will be the focus. Okay, the focus of the parabola. Okay, so the distance of the vertex to parabola is 2 cm. Okay, and that is equal to p distance. Okay, then the also even, so knowing that the bulb center is 2 cm from the vertex, then the radius of the base of the headlight reflector is 10 cm. So take note, this is a radius. Okay, so you have 10 cm. Then we are tasked to determine this one. Okay, so the height. Okay, so if this is P, then if the bulb is in the focus, then we can draw a latus rectum here. Okay, okay, so take note that latus rectum is equal to 4p, and we have this value here 4p, which is equal to 2 cm. Okay, so we have 4 then times p, so which is equal to 8. So that is the length of the latus rectum. Okay, so if the radius is 10 cm, so if we will make it 10 cm. Okay, so to determine h, so again we will be doing the square property of the parabola. Okay, so we have this height h here, height h, then over, so the base is 20. Okay, so 20 squared, then equal to, again the height, this is 2 cm, 2 cm over the latus rectum, which is equal to 8 cm, so 8 squared. Okay, therefore the height of the headlight reflector is 12.5 cm. Okay, so that's all for parabola. So the next topic will be ellipse. Okay, so stay tuned for our discussion for the topic ellipse.